airspace. So the idea is to have like a digital twin of the airspace. It is to essentially be able to recreate the real world as a digital world, and then not just have it as a digital twin, but also like as a living twin, where it is learning based on the data that we are feeding it, and it is improving, and it is becoming better at predicting risks or predicting incidents or predicting non-compliances by drones or operators, or it is able to predict certain behavior in traffic or issues in traffic based on prevalent weather conditions, network availability, or GPS availability and things like that. So that is where we are headed. But more importantly, what's going to be available in Astra at the end of this year is going to be automated flight path planning. So one of the reasons to do terrain and obstacles and be able to map them and utilize them is to essentially say, to drone operators, because if everyone wants to fly, so we need to optimize routes and we need to kind of resolve the conflicts between these flights. So if someone says, I want to take off here at this corner and go here, they cannot, of course, take off 10 meters and then go straight because there's a building in between. So you tell us as drone operator, what's your starting point, end point, what's the use case, and we will give you a flight corridor, automatically through the system. No human has, is going to be able to do it, of course, for let's say 5,000 drone flights simultaneously, but the platform is with enough compute processing and bandwidth on the cloud, we can achieve automated flight path planning for drone flights, and that is where we're headed by the end of this year. So that is Expo 2020. So I'd also like to then talk a bit about our implementations elsewhere, and give kind of like an overall view of where we are. So these are the countries where we've operated, and also I'll talk about a bit about the projects that we've implemented in these places. So in Finland, we are currently deploying the system solution with Traffic ANS, who are the national air navigation service provider in Finland. They are using our system to offer the preliminary UTM services such as registration or flight authorization or flight application for drone operators. There's a slight unique scenario there in Finland where they are also using our UTM platform, which was like surprising for us, but also validation of how customizable, configurable, and powerful the system is. But they're also using the system for VFR and IFR flight planning services as well, which comes from, of course, manned aviation. We have another project in Finland which is led by VTT, the Finnish research organization, called Drolo, and Drolo is going to be like a use space demonstrator, obviously facilitated by VTT and Traffic ANS, who are going to deploy the solution in the Oulu region of Finland and use drones and fly drones, around medium-sized international airports or a medium-sized international airport, seaport, inhabited island, and a medium-sized city center as well, over 4G, 5G cellular network. The idea is to demonstrate how a use space can be managed and how a use space can be dynamically reconfigured. So when I'm saying use space, I mean airspace that is reserved or dedicated for drone use. Now there might be scenarios because there's a finite amount of airspace available, where you might have to dynamically reconfigure an airspace, make it a drone airspace, and then also transition it back or switch it back to controlled airspace where manned air traffic can operate. Manned air traffic by today's regulation cannot operate in use space. If it does, then it ceases to be use space. Then our UAE implementation, the Expo 2020 implementation that I was talking about, where we essentially for 6 months, for the duration of the event, we manage the airspace and the approvals through the UTM platform, and touch wood, we managed to deliver the event and the airspace management for the event without any drone incident, tracking and monitoring flights non-stop for a period of 6 months. We have the one that we ever had, which was with the Vice Aviation Authority, and that system is like the previous version of ASTRA UTM or Urbuster that is still in place at VCAA, Vice Aviation Authority. We are also in Canada, where we are providing ASTRA UTM as a core traffic management solution for a 425 kilometers of airspace corridor that is being utilized for oil and gas pipeline inspections. And again, the implementation integrates or leverages the cellular network that is provided by the leading telco in Canada called TELUS. And they're going to be tracking drone flights over the cellular network. Essentially, the use case will be oil and gas pipeline inspection and surveillance services, with the mandate and the scope to then, once you've got the infrastructure and the airspace corridor and the UTM services available, then you can do other sorts of drone flights using the same infrastructure. We have, sorry, someone needs to move the mic so I don't get the feedback. Yeah, it's better now. Okay, so VV loss is when drones go beyond visual line of sight of the pilot, the operator that's operating them, where the pilot cannot see the drone anymore and it is not in their line of sight. So that is where the true value of drone is unlocked, where you don't have to visually see it and track it and fly it, and the drone can pretty much go on an automated autonomous flight path, flight mission, and perform a certain task or stream or collect a certain type of data. So that is what we were engaged in with ENAV to trial these beyond visual line of sight flights, where these were being tracked and monitored through our platform. We've also worked with New Zealand NSP Airways, where we built the backend for their UTM system called Airship. So this is where I usually pause, and I would then perhaps request for any clarifications or questions from anyone that would wish to ask questions. And I would perhaps begin with Fernando. And Fernando, if you think I haven't covered any topic, or you wish to perhaps provide some clarifications on a certain topic, then please let me know now.
Well, it has been a really good presentation, and thank you very much. I would love understand, because of a question that I received yesterday, how is the integration with the ATM? Because we can extract information from ATM, but not inject information to the ATM. So how is that done by Astra?
Right. So you're absolutely right. We can ingest, we can import, we can take in information, and it's not a straightforward exercise to also take information from ATM systems. It requires parsing of data. It at times might require data fusion, but if the data is already fused and is resolved for you, then you just it becomes a straightforward matter of taking the CAT62 format data and visualizing it and utilizing it for separation of manned and unmanned drones. So we take the onus of separating or keeping drones away from manned air traffic within the UTM system. However, drones might operate at times in controlled airspace, which means that they need to be also then be seen in conventional ATM systems. Now, the ability or the inability to do that needs to be looked at in that ATM system, whether that is capable of then taking data from our system and visualizing it and utilizing it. We have the ability to also then not just provide, in fact, we have a multitude of APIs within Astra for every single service that we perform. Astra is a cloud-based, microservices-based, it's a containerized Kubernetes architecture, which means that every single service in Astra can be kind of provided to a third-party system via APIs. So, which also then means to ATM systems. Should the ATM system be capable of consuming information, we would be able to provide it to them. Now, has anyone done it yet? NSPs are a kind of like a very demanding customers, so they need certain things to be certified before they integrate with them. And we are, of course, in the process of then, along with the European implementations that we have to certify our UTM system and hopefully, then also integrate and, also pass the data back onto the ATM systems.
Great. And another question is mostly from pilots, which are used to manage their systems from their smart controller, not from the cellular phone, because they are afraid to get disconnected because of a call or of a message. So how Astra integrates into the smart controller management and the telemetry operation?
Right. So smart controller is Android based. So we're actually working, and we already have a prototype available for an Astra application that will work on smart controllers as well. Now, in the absence of the operator's comfort, to then not use a native DJI app, there's always the option to attach a transponder, a tracking device on the drone. But we are providing an Astra version which has the capability to stream telemetry to the UTM system and also provide the native smart controller features using the Android Astra application meant for DJI smart controllers. Question?
Yeah, I have a question.
Sure.
So, can you hear me?
Yes, I can.
Yeah, well, first of all, thank you for this so interesting presentation. And my question is more focused on
Is there feedback on the room you are?
oh, I can do it without this. Hi. Right now it's okay. Okay, so yeah, my question is more related to the more general benefits that this platform or this solution can bring to the public agency, to the National Public Safety Agency.
So more general benefits.
Yeah, could you please summarize them?
Yes, absolutely. So the first thing I mentioned the way that they look at civilian aircraft and aviation. It's not another form of aviation. Drones aren't just another form of aviation. They are so drones are a new form of aviation. They're not just another form of aviation, and the reason for that is that they're going to be based on these vertiports that might be next to communities or buildings or high rises, and integrate it into communities, whether that's drones for doing, carrying people or humans, as is, very, concerted effort by a lot of companies, or drones doing last mile and mid-mile deliveries, or whether it's drones collecting data, video, incident response, emergency services, or things like that, which means drones are going to be very close to ground. And for that to happen at scale, where you might have thousands of drones in a city airspace at any given point of time, where, I don't want to paint a very, future where, the skies get dark because of the number of drones flying, but drones, in large numbers could effectively become, a concern from a public acceptance point of view as well. There is concern around noise, with drones. There is concern around, safety and privacy and whatnot. So the benefits of a system like ours are essentially at the, authority or an agency level, is to first establish a system and visualize what is the airspace available, or, what is the total utilizable airspace for drones, and how can we, then minimize the impact to ground or people or, infrastructure, and do it in a way that also then delivers capacity, and do it in a way that also delivers safety, and do it in a way that also delivers viable commercial use cases as well, which have, an ROI based on, now using drones instead of however which way it was done conventionally for that particular use case. Now, so that is the, in itself, the ability to have a system that will help you manage, but not just then manage, then also learn and visualize and study and implement the overall ecosystem, is an essential tool and is an essential technology for the agencies. We are building modules, for example, around noise optimization. So the example we give is, let's assume that someone's house happens to be between two Amazon warehouses, or an Amazon delivery port and an Amazon warehouse. And a straight line every time over that house, that person is going to hear the drone buzzing past their residence every, let's say, 30 seconds or 2 minutes or whatever, and that's going to be that's going to leave a very negative experience for that drone, for that person living there in this flight path, in this route, which happens to be just the fastest path between these 2 points. So what we are looking at is then perhaps randomizing drone flight paths across certain corridors, so as not to send drones flying over communities or certain houses or housing or people, even though that is essentially the fastest point between point A and point B, fastest line between point A and point B, but to randomize it. So we are also dealing with then the concerns that communities will have around noise management. So again, it's not just safety, then it's also the commercial viability, and it's also then the community acceptance and all of these things. So any authority would want to have the system and the ecosystem to be able to deal with that. The other one is also not every airspace, or not all airspace is controlled airspace, which means that controlled airspace is where traffic is controlled by air navigation service providers, and it is declared as a controlled airspace. But there are lots of places with lots of uncontrolled airspace, which means that no one has a say in what happens there. It's up to the users of that uncontrolled airspace to ensure safety in that for their operations. So there, then what happens is you could effectively then, as let's say, for example, municipalities or councils or state governments, then say, we have this much of controlled or uncontrolled airspace, and we would want to implement a system which would then generate a whole new layer of, let's say, trigger or ignite a whole new layer of, economy, which is around utilizing that, or providing services or drones in those that were previously in airspace, but now can be configured into use space or dedicated for use by drones. So I hope I didn't deviate too much from the initial question, but the idea is that there are a lot of benefits, and there's it unlocks a whole new layer of capabilities, and it also provides a lot more insight for authorities to have systems like these in place. Okay, so I have another question from Martin Gomez. Christina, could you please explain the different phases of a project and how long it takes? So the way Astra has been built and architected is, like I mentioned, it's a module-based system. So not everyone uses everything in Astra. We understand that. So we even have a point of sale module, which lets you integrate Astra UTM with retail outlets, where if they're selling a drone, all they do is scan the serial number barcode and enter that into Astra, and also enter the contact details of the person that is buying the drone. So they're kind of pre-registering that operator or that buyer of drone as a user of the UTM system. So the authorities are notified that this person bought this particular drone, and they're using it for hobby or commercial activities or whatnot. So we have that model, but we understand that not everyone wants to use that capability. So we've built this as very modular, as very loosely coupled systems, so you can kind of customize workflows and or reconfigure, reorient workflows, and Astra will still kind of perform to whatever needs you might have. So having said that, what that means then in terms of phases of a project is we have an as-is version. So we have like an a la carte menu of capabilities that we can offer to a client, whether that's at the government or authority level, or whether that's at the enterprise layer with large enterprise who would need a solution like this for centralization of drone flight data, or fleet management, or compliance, internal compliance and conformance, or internal approvals. So they use a system like this, or whether it's eventually what we see is happening is like a direct to consumer service where drone operators are directly subscribing to the UTM system. So it depends on what who we are dealing with and what their requirements are. So once we provide the modules, they either it meets their requirements, or they need certain types of configurations. They need integrations, which is essential. They need integrating our systems with conventional or legacy systems, or they would need a certain source of weather data. They would need a certain source of terrain and obstacle data. They would need a certain, let's say, network coverage mapping from a certain telco. And all of these exercises, essentially, vary in complexity and the time they take to deliver. But ideally, an NSP level implementation can be delivered in 3 to 6 months, depending, all the stakeholders, do what they're supposed to do. But an enterprise level implementation, where, it's an over the cloud service, can be, set up in a day by plugging in the data sources that the enterprise needs and deliver it to them within the day itself. Or if they require configuration customization, that would then take longer. Then right now, what we also have is a lot of these sandboxes and pilot projects, which are trying to prove to the authorities, lobbying to the regulators, lobbying to the governments that this is how drones can fly. We can track them safely. We can perform these flights safely, and this is the infrastructure and ecosystem needed to do that. And like I said, we're part of one of those demonstrators called Drolo in Finland. So we went into a requirement gathering exercise of 30 days and trying to identify every single touch point with third-party services, systems, and participants in that project. And based on that, then we went into the implementation, customization phase for another 30 days, and then we were ready to deploy. So I hope that answered the question, Christina.
Can you please explain how we help police officers or firefighters with Astra to reinforce the law or help control drones flying without approval?
Right. So there are actually more than just one, use case there that we can provide as a benefit. Let me just quickly switch on and off. Yeah. So what we have for for law enforcement is unauthorized drones is always going to be a concern, and drones that are being flown as either as a nuisance, simply as a nuisance, where there is no malintent, will also cause issues, regardless of, how innocent the person is, so to say. And if they're flying, without knowledge of regulations or without concern for safety of others or other aviation around them, that is going to end up, in potentially, a disaster. Then you also have drones that are being flown, could be flown, might be flown with malintent, with the intent to cause damage or cause trouble, and while these are not, 99% of the cases are always, people flying for, the overall benefit of the society, but there is that 1% chance that people fly drones for any, nefarious activities, which might even smuggling or, unauthorized surveillance, spying, and things like that. So here is how we look at that problem. We see that as a three-step process. So we see that as being able to first detect all kinds of drones, all drones in the airspace. Two, then identify all the drones to be able to validate and verify the identity of these drones. And three, defeat these drones. So it's a three-step process: detect, identify, defeat. Now, our system, is based on the very premise that operators are going to be compliant. They are going to follow the rules. They are going to put a tracking device on, or they're going to somehow network their ground station or their autopilot system and share their position with the UTM system. That is the underlying premise for our system. And there are no two ways about it. But what that then means is, if we can tell you who the good guys are, what you need to do then as law enforcement is to, put in the required infrastructure, which can be, radars optimized for detecting drones. Now there are radars, that used to miss drones because, they were optimized for bigger, cross sections of reflection from the big aircraft. But now there are radars that can detect drones even as small as Phantoms or Mavics as well. And we've seen those in use here in the region as well. And there are then, other means of detecting drones, which is by using passive RF antennas, radio frequency antennas, that are just listening to any activity between the controller and the receiving unit on the drone. And they can then listen and identify, detect, this is a drone, this is where the operator, I can localize this by multilateration, this drone is here, this operator is flying here, and then this drone is in this particular area in the airspace. And so you can try to detect drones using those technologies. Those systems do not have the intelligence of a UTM system. So they will detect everyone. Okay, now I'm detecting 10 flights with with a combination of these sensors, but which one of these 10 flights is the bad guy? So those systems will not have that intelligence unless you have the registration data linked, unless you have the flight approval data linked, unless you have the drone serial number linked. So how do you do that? You do all of that using a system such as ours. So the process becomes detect using all this infrastructure, radar, RF, and what have you. Then, interrogate the UTM system and say, I'm detecting 10. How many are you detecting? How many are transmitting? How many are reporting their position out of these 10? And we send that back to them. And that's what we've done at Expo, where we have integrated with a counter-drone system, is we send all the cooperative data feed into the C2 counter-drone system. And they see, okay, there are 9 flights happening, which the UTM system is reporting as authorized and approved. This guy, the 10th guy here, he's the problem. He's the unauthorized flight. He or she is the unauthorized flight. And that is, then the identification and validation. Now, what happens after that is, of course, up to the enforcement, up to the law, is whether they want to then shoot it down, or send an eagle to catch it, or throw a net at it, or jam it with an RF jammer, or just let it fly. That is up to the authorities. So hopefully, that addresses the way that we can support law enforcement agencies into curbing or catching the use of non-compliant drones, or non-cooperative drones as they're also known. So that's one of the ways. The other way we can support law enforcement agencies and authorities is we've also prototyped a capability and a solution within Astra ecosystem called X-Link. And what X-Link does is it's essentially a companion computer module that we've built. And it works over 4G and 5G networks. And what this X-Link companion computer module does, it's something the size of this mouse here, slightly bigger. And what X-Link does is essentially you can connect it, plug it into any Mavlink based drones, which is like the widely used protocol for most of the open source drones, using ArduPilot, and Pixhawk and all that combination. If you plug into any of these Mavlink based drones, those drones become smart drones or connected drones. And those drones get pre-connected to Astra UTM platform. What that does then is, if you have a network drone or a connected drone, is you can fly it remotely. You don't have to be out in the field. As long as you have cellular coverage, you have network availability, you can be sitting in Madrid and flying a drone in Dubai, which we have done, by the way, last year, where we're at the World ATM Congress, where we're flying a drone in Dubai from Madrid over the network, over the internet, basically, essentially, and using just an iPad, sending a flight plan to the drone, and the drone is remotely taking off. What that also allowed us to then enhance that system was to customize the system in such a way there was an operator profile and an authority profile. So an operator profile within that instance has the override authority over any drone flight. So any drone, any network drone that is flying at any given point of time can be stopped from flying by the authority that has the right sort of privileges defined in the system to be able to do so. So they can stop a drone from flying, take control from the operator, where the operator will not have any input with the drone anymore. The drone will refuse to listen to the operator and will only listen to an authority with higher privileges over the operator. And then the authority can then trigger certain automated actions, which is return to land, return home, or land immediately, or also manually fly that drone using a joystick, and which is again what we've done. And what we are hopefully, given that this is in Madrid, the presentation, we are going to be exhibiting at Madrid World ATM Congress in June, and we're going to be presenting that capability there, where we can override the access of a particular operator. So this might be of interest to law enforcement agencies, where they would want to have that sort of capability, where they can override control or stop drones from flying in certain applications. We do not propose this or see this being utilized for every scenario, but certain scenarios might require that sort of capability. Fernando, did that answer the question, or would you want me to touch upon something else within that?
It's clear for me. Just wanted to see if anyone in the call is having more questions, or in the chat. I have so much more questions, but
there is no more questions.
And the other feature that we have is to connect with insurance companies, because governments ask pilots to have insurance policy for flight, not for the system, but for flight, to protect third parties. Can you explain how we connect to those entities?
Insurances, yes. So there are already insurance providers that are now that provide custom kind of tailored coverage for drone flights. Back in 2015, when we deployed the solution, there was no insurance cover for drones. And while there was coverage for third-party liability, there wasn't one using or caused by drones, so to say, that drone operators could. And there were then a few insurance brokers that worked on kind of with the insurance companies and came up with these annual premium packages for drone operators where they could, also insure the hull, but and also have the capability and the facility to have third-party liability coverage as well. So what we foresaw at that time was, this is an annual premium paid by an operator who might only be flying for one day in the whole year or just once every month. And why not then have the system or workflow designed in such a way where insurance service providers get all the required info that they need for that particular operation and that particular operator, over the web, over an API call, where they can then return using their whatever complex calculators they use to return to the drone operator a pay-per-flight, a pay-as-you-go insurance, so that covers you for today. So you want to fly for 3 hours, I will cover you for 3 hours, and this is how much it will cost you. It will cost you 12 euros to cover you for third-party liability for this flight. So, it's not an endless coverage, it's only for the next 3 hours, based on what the system is telling the insurance provider, that this is a, certified operator is flying a drone, or he or she is flying a drone that weighs 249 grams, it's in uncontrolled airspace, it's not overpopulated areas, and, would you like to insure them? And that is then real-time, insurance provision for insurance coverage for drone operators. We see this, extending then to, to very big scale in terms of providing coverage in a pay-as-you-go form. Now, it might not again apply to all the scenarios, but hopefully it becomes, where that commercial freelancers and filmographers and one-off drone operators would like to have that sort of coverage capability available. But if you also want to provide, or sell insurance services through the UTM system to large enterprise to cover their whole fleet or cover certain types of high-risk operations, then, the system will be able to validate all that information, all the risk assessment from an aviation point of view, safety assessment of that flight with the insurance service providers, so operators can then have coverage as well in a more, let's say, scientific manner than what they would be otherwise able to communicate to the insurance service provider over, a series of email exchanges and paper trials. We will be doing, very quantified risk analysis of that particular operator and that particular flight. Okay, so next questions. How many drones can be managed by the platform, for example, in the Expo? There is no limit, essentially, Christina, because this is a cloud-based solution. So if you have, requirements to manage just 10 drones or 20 drones, then the sizing of the infrastructure that our solution sits or is hosted within will be fairly, minimal. But if you then need to scale it up to managing, let's say, 500 drones or 1,000 drones simultaneously, concurrently, then all the system sits in an auto-scale environment, in an auto-scale infrastructure environment. So it's an on-demand, so if we have more, demand on telemetry streaming, then those microservices and the associated containers that they sit within will also scale. And deconfliction system, could you explain how it works? How does deconfliction work? Yeah, that's a very valid and good question. Deconfliction is kind of like, what we early on thought of as the holy grail of how this thing will scale. How deconfliction is delivered today is very strategic. It's very, before the actual event happens, you are trying to resolve that conflict by not encouraging overlap. So if you have a certain drone going from this point to this point, then you will just, give that drone the corridor, and you will not give any other drone a corridor that is crossing this corridor now. And that's how you deconflict. So you pre-resolve the conflict. You say, no, strategic deconfliction, there's a drone flying here, I cannot let you fly there. So no two drones can be in the same place at the same time, simultaneously. So what we then looked at was, given the very fact that we can track and monitor drones in real time, why can't we, then also deconflict? So what do we need to look at to deconflict drone traffic? Compliance and conformance notwithstanding, what are the parameters that you need to look at? And the parameters that you need to look at is the heading of the drone. So there might be two drones very close to each other but flying in opposite directions. So they're not really, a cause of concern for each other because they're going in opposite directions. So heading is something that you look at. And if there are two drones really far away but they're approaching each other head on, then they might at some point of time, collide with each other. So we look at heading. We look at horizontal and vertical separation as well. So if there are two drones that are, again, facing each other but moving like this, with enough vertical separation between the two, again, not a matter of concern. They can cross each other safely. Or they're at the same altitude but separated by, horizontally, and they're moving away from each other. No problem again. So we look at heading, we look at the time of arrival, the speed of these drones, we look at the vertical separation, we look at horizontal separation, and the algorithm based on all this data is then, assessing and calculating whether this is a conflict or not. It advises them to, either increase horizontal separation or increase vertical separation or change heading orientation so they can cross each other safely. Sorry for the hand gestures. This was the only way I could perhaps explain it or have the ability to explain it. But I hope that answered your question. Okay, I'll assume it answered your question. Yes, thank you.
And usually for innovation, cities would like to deploy a show of a swarm of drones to exhibit, to ignite interest on the people. How we did that on previous situations?
Yes, we have managed the drone light shows that were part of the Expo 2020 event as well. So while the drone light shows, when these happen, they're like a swarm of 200, 300, even 500 drones flying all together in a formation, pre-programmed formation. And so there are two ways to do that. Either you ask the drone light show operator to connect their ground station directly to the UTM system, or you can design a bubble within which the light shows drones are supposed to operate for that light show and prevent other drones and other activities happening in that bubble for that duration of that light show. But what our system does allow is to kind of visualize which airspace this light show will happen within, and then what needs to be segregated and separated from that light show. Okay. Any more questions?
Well, I think that there is no more questions. Thank you very much, Ayan, for the presentation. It has been really interesting. And well, thank you also, Fernando, for all your questions. And thank you very much for J's Group por esta oportunidad. And thank you very much.
Thank you, Christina. Thank you, everyone, for hosting us and giving us the opportunity to present our solution and story. Should there be any questions from anyone that was part of the presentation today, please do drop us a line, either to Fernando or to info@Astra UTM, or my email ihan@AstraUTM, and we'll be happy to kind of provide again further information and share more insights and knowledge that we've gathered over the years.
Thank you, Ihan. Very interesting. Thank you very much.
Thank you, Ihan.
Thank you, Christina. Thank you, Sandra.
Take care.
Bye.
Have a good day.
Thank you. Bye-bye.
Bye. Bye.
You can see Jill and Carmen.
Yes. Hello. Bye.
Thank you. Bye.
All right. Dropping off now. Thank you, everyone. Take care. Bye-bye.